In the fourth and final part of this video series on graphics and GUIs, we will examine several other GUI components and provide one example that incorporates them. Finally, we will discuss GUI generators and declarative methods for defining GUIs. The first GUI component that we introduce is combo boxes. A combo box allows the user to select from a list of choices. Only one choice from that list can be selected, so it is an alternative to using radio buttons. One reason that it might be preferable to using radio buttons is that it requires less screen space. Additionally, it has one other optional capability that is not available with radio buttons. Combo boxes can optionally be editable, which allows the user to enter input. An example of a situation where this feature might be useful would be with entering a date. The user would select the date format from the list of choices and then enter the actual date in the editable text field. When handling the events associated with combo boxes, the same listener is used as was used with radio buttons and checkboxes, which is the item listener. Inside the event handler, the getSelectedIndex method must be called to determine which item was selected. The next GUI component that we will discuss is sliders. This component is a metaphor for a mechanical control that is used on some audio systems as a volume control. Sliders allow the user to select a value in a range by adjusting the slider. A common use of sliders in animations is to allow the user to control the speed of the animation. Slider event listeners must implement the Change Listener interface. The state change method is called when a slider is adjusted. It is the only method in the Change Listener interface, so that interface is a functional interface, which means lambda expressions can be used for the event handler. In that case, the code never needs to explicitly refer to the state changed method. Inside the event handler, calling the getValue method is used to determine the new slider position. The default range of values is from 0 to 100. Lists are the next GUI component that we will discuss. Lists allow a user to select one or more items from a list of choices. Consequently, they are an alternative to using a collection of checkboxes. As with combo boxes, one reason that using a list might be preferable to checkboxes is that it requires less screen space. List listeners must implement the List Selected Listener interface. The value change method is called when a new selection is made. It is the only method in the List Selection Listener interface. So that interface is a functional interface, which again means lambda expressions can be used for the event handler. Inside the event handler, calling the getSelectedIndeces method provides the items that were selected. It returns an array of indices because more than one value can be selected. This program illustrates the use of the three different types of controls that we just discussed: a combo box, a slider, and a list. Each of them influences the drawing of the circle in the colorable circle class used in previous examples. This declaration instantiates the list that has three choices: red, blue, and green. Because more than one can be selected, the result can be any of 8 combinations of the three primary colors. The next declaration instantiates the combo box that allows the user to select from one of 5 different intensities, from darkest to brightest. Finally, the slider is instantiated in this declaration. It will be used to allow the size of the circle to be enlarged or reduced. The array color mix is the array in which the result of calling getSelectedIndeces will be stored. It will contain the desired combination of red, blue, and green. It is initialized to contain all three, which produces some shade of gray depending upon the intensity. The variable shade will be a value that corresponds to the intensity. Its initial value of 1 corresponds to darkest. Let's scroll down to the constructor. The control panel will contain the combo box, list, and slider. We are using a layout manager that we have not used before, which is box layout. It is useful for arranging components either horizontally or vertically. The second parameter, boxLayout.y-axis, specifies that we desire a vertical layout. First we add the list colors, then a box create rigid area is added to create some vertical separation between components. Next we add the combo box intensity, and finally the slider size adjuster. This is the event handler for the list colors, implemented with a lambda expression. It extracts the array of indices selected by calling getSelectedIndices and stores it into the array color mix, and then calls the private method setColor that will determine the color based on the color mix and intensity. We will examine that method shortly. Scrolling down to the next two event handlers, the next event handler handles events from the combo box intensity, again implemented with a lambda expression. It extracts the intensity level with a call to getSelectedIndex. It stores the result into the variable shade and adds 1 to it so that the range of shades will be 1 to 5. Then it also calls the private method setColor. The final event handler handles the event generated by the slider size adjuster. It extracts the value with a call to getValue and passes that value to the change size method of the colorable circle class. Because getValue returns a value of type double, it must be typecast to an int before it is passed to change size. Finally, let's examine the private method setColor that is called by the first two event handlers. It computes a single hexadecimal value for the color by combining the color mix and intensity using this array color values. It contains 3 hexadecimal constants. The prefix 0x indicates that these values are written in hexadecimal. The hexadecimal value 33 is the result of dividing the hexadecimal value FF by 5. When the variable shade is multiplied by this value, it will produce one of 5 intensity levels. The first value of the array corresponds to the red component, the second to green, and the third to blue. This loop generates a single hexadecimal value that represents the final color by multiplying the specified components by the shade and adding them together. It then calls a constructor of the color class that generates a color from that value and passes it to the change color method of the colorable circle class. Let's run this program to see how it works. First, let's move the slider to see how the size of the circle changes. Next, let's change the intensity. Finally, let's make some changes to the color mix. Our next topic is text areas and scroll bars. Text areas can be used in place of text fields for input that is expected to be very lengthy. As one would expect, the name of the class is JTextArea. Several of the constructors for that class allow us to specify the number of rows and columns. It is often desirable to add both vertical and horizontal scroll bars to panels that contain text areas. Adding them allows the text that exceeds the size of the text area to be viewable. Although scroll bars are most often used on text areas, they can be used on any type of panels. We conclude this discussion of GUIs with a discussion of alternate techniques for generating GUIs. Using a GUI generator is one such alternative. Most new IDEs provide the ability to define a GUI using a GUI generator, which is a graphical tool that allows the designer to see the GUI as it is being defined. One of the benefits of this approach is that such tools allow a GUI to be developed more quickly. These tools produce the Java code needed to create the GUI. One of the drawbacks to this approach is that the generated code can be a bit hard to read. When we write the code ourselves to generate a GUI, we are providing instructions on what to do at each step. That approach is imperative. Another alternative is to provide a declarative definition. HTML forms are an example of a declarative GUI definition. Using HTML tags, we can specify components such as ordinary buttons, radio buttons, and so on. Android apps are written in Java, but do not use the swing and AWT toolkits like ordinary Java programs. The GUIs are defined in a declarative fashion using XML. The XML tags are similar to the ones used with HTML. The system then inflates the XML code that produces the GUI. The inflation process is similar to what occurs when GUI generators produce Java code.